So this is workshop on sample size calculations and day one. And on day one, these topics will be discussed. So as you know that sample size calculation is very essential. As Supal ma'am told that many research papers got rejected due to when we don't calculate sample size in accurate way. Okay. So we have to know about prerequisites for sample size calculation in health research or in any research. So there are some prerequisites. What the things we have to keep in our mind before calculation of the sample size. And after that, we will discuss about sample size calculations in different scenarios in health research. That is, if we have one group, if we have two groups, okay, and we can calculate sample size for more than two groups also, no issue. Sometimes, generally, we are calculating sample size for prevalence, for proportion, for incidence, for percentage. For example, number of patients or percentage of the patients have this much event. For example, around 30% of the patients, 30% of the patients have died, okay, or have this outcome of interest, 30%, 30%, 25%. So this is prevalence or proportion. And if there is a single group, only single group, for example, in a descriptive or cross-sectional study design. And when we have single group, but instead of prevalence or proportion, we are calculating sample size for mean and standard deviation in a descriptive or cross-sectional study design. Okay, we have single group and we have prevalence and proportion. For example, so much 30%, 20%, 2%, 18%, 90%, 60% of the participants or patients have this event of interest. Okay. If we have mean and standard deviation, for example, mean of hemoglobin, mean of creatinine, okay, mean of quantitative variable. And what are quantitative variable? These are numerical variable. We can see, for example, systolic BP, diastolic BP, creatinine, HB, score, health related quality of life. Okay, if we have our outcome is health related quality of life, so for this we can calculate mean and standard deviation. Okay, these are quantitative variables. And when we talk about categorical or qualitative variables, then we have to calculate for sample size from prevalence or proportion or percentage. Okay, so for qualitative or categorical variable, we have to calculate sample size from prevalence or proportion. And when we have quantitative type of outcome variable, we have to calculate sample size using mean and standard deviation. Whether we have one group, whether we have two groups or more than two groups. Okay. Sometimes we have medians or interquartile range instead of mean and standard deviation. So how we calculate sample size using this median and interquartile range, I will give demo. And I will give demo on various sample size online calculators. So these online calculators make our life easy to calculate sample size. But main or major thing, what is, we have to remember these prerequisites we have to, okay. So I'll show you, okay, what are the prerequisites we have to know before calculation of the sample size. So as we know that sample size calculation in any research is an essential step to avoid over and underestimation of the outcomes. And health researchers, being health researchers, we should prior estimate before starting of our study or research. We have to estimate sample size before starting our study, which help in validity and reliability of the research findings. It is very essential. If research is validated or reliable, we can generalize this research finding. Okay. So for sample size calculation, it is very essential. And it is an important part of research design. And sample size must be carefully calculated prior to conduct research study to make sure that the time to conduct research, personnel or researcher efforts, and money are not wasted unnecessary. So sample size must be carefully calculated prior to conduct a research study. Okay. So when you are going to plan any research study, you have to calculate a sample size prior. Okay. But sometimes what happened, we cannot calculate sample size prior, but after, and we send our paper to any journal and reviewer give comment, okay, calculate sample size for this, but like we didn't calculate sample size. So they give kindly calculate post hoc power calculation. Post hoc power calculation. So after completing our research, and when we send this research to any journal for publications, and we didn't calculate sample size for that research paper, so there is one comment, kindly calculate post hoc power calculation. So I will show demo on that also. If we have done research study, we didn't calculate sample size due to any reason. So there is one general comment that you have to calculate post hoc power calculation. Post hoc means after your study, you have to calculate power of that study. Okay. So these are prerequisites for sample size calculation in health research. So you have to remember, sample size calculation is based on your primary outcome. So in your research study, in your thesis, in your dissertation, there must be a primary outcome. Okay. Other are co-primary or secondary outcome. So sample size always must be on your primary outcome of your study. Okay. Proportion, prevalence, incidence, these are for qualitative or categorical variables. Okay. Type of data or variables. Mean and standard deviation, these are for quantitative type of variable, etc. You can take from a previous study or from a pilot study or expert opinion, your clinical experience, or even on the basis of your assumption. You can assume. So for sample size calculation, we have to take prevalence, proportion, percentage, incidence, or mean or standard deviation. So whether we can take it from previous study, similar type of previous study, it is very good thing. Okay. So if we take these findings to calculate our sample size, if you take it from a previous similar study, it is very good. But if we don't have this similar type of study, previous type of study, we can conduct a pilot study on like 5 patients or 10 patients or 10% of our sample size. Suppose you are conducting a study on, for example, you are thinking that I'm conducting on 100 sample size, then you can take 10 samples. You can do pilot study. And then these pilot study, what you are getting prevalence, percentage, proportion, mean, standard deviation. Then you can calculate sample size on the basis of this pilot study results. Or you can take expert opinion. Okay, expertise opinion, and you can take your clinical experience also, and even you can assume. Okay, so there are two things. Number one is sample size must be calculated according to your primary outcome. Number two, you have to take a reference from previous study, or you have to do pilot study, expert opinion, clinical experience, or your assumption. Assumption is very easy. Okay. So power of study and confidence interval. So in health research, usually we are taking 80% power or 90% power. Okay. 80% or 90%. Sometimes you are calculating sample size on 80%, and sometimes you are calculating sample size on 90% power. And confidence interval, it is usually taken as 95%. I'll give demo, okay, how we take these things. So you have to remember, for sample size calculation, prerequisites are your primary outcome. What is your primary outcome? On the basis of this primary outcome, you can calculate sample size, not on secondary or co-primary outcomes. Only basis of primary outcome. Sometimes if you want to calculate sample size on primary, co-primary, secondary outcome, you can calculate, no issue. You can calculate according to your guide and co-guide suggestions. Okay, you can calculate. But what happened? Which sample size is bigger, you have to take that sample size. Suppose you are calculating sample size on primary outcome, it is coming around 100. But if you are calculating sample size on co-primary and secondary outcome, it is coming, for example, 150. Then you have to take 150. You cannot take 100. So this is general rule for sample size calculations. Okay. Then previous study, pilot study, expert opinion, clinical experience, or assumptions. Now you have to take power of study, 80% or 90%. Not below 80%, no need to take more than 90%. So please remember 80% or 90%. And confidence interval, always take 95% confidence interval for calculating sample size. So you have to remember 4 things. Okay. And when I'll give demo hands-on, then we will discuss all these things again and again. This is a table. It is very complicated table, but what you have to remember in this is standard normal deviate function values, means Z score value, Z value. You have to remember this. Standard normal deviate function values means Z value, Z score value, Z value, Z. You have to remember this, okay? So what you have to do, you have to, okay, first we will read this table and then I'll give what you have to remember from this table. So you can see here, you can see my cursor here. Okay, right, left upper corner, you can see alpha, it is called type 1 error, or beta, it is called type 2 error value. Okay, so when we calculate sample size, this alpha, sometimes beta, we have to use, okay, alpha and beta. So these are some alpha and beta value you can see here. 0.2, 0.15, 0.1, 0.05, 0.025, 0.01, 0.001. You no need to remember all these things. No need to remember. What you remember, I'll show you. Now, when we talk about power of study, you can see power of study means 1 minus beta. That is power of study. You have to remember every time. So what do you mean by power of study? Power of study is 1 minus beta. And what is beta? Beta is type 2 error. Okay. So this is 1 minus beta. And when we talk about type 2, type 1 error, so what do you mean by type 1 error? So for this, we have to remember hypothesis. Okay, in hypothesis, when I say type 1 error, so what is? Reject the null hypothesis when it's true. Okay, reject the null hypothesis when it's true. So it is an error. Null hypothesis is true, but we are rejecting. So it is an error. It is called type 1 error or alpha error. And what is beta? Beta, accept the null hypothesis when it's false. Okay, we are accepting, we are not rejecting null hypothesis, but in actual it is false. We should reject it, but we are not rejecting. So what we are committing an error. And what is error? It is called a type 2 error. And what is power of study? It is 1 minus type 2 error, 1 minus beta. So when we take type 2 error is 20%, okay, it means 20%, okay, we are 20% of the time we are committing type 2 error, means we are accepting null hypothesis when it's false. So it is coming, this is, you can see here, this is 0.2, it means it is 20%. 20% means 0.2, okay? So when we took 20% as type 2 error, 20% is type 2 error, beta means 20%. So what we have to do, we have to write here 1 minus 0.2. So it is coming 0.8, it is 80%. So what do you mean by 80%? It is a power of the study, that is 80%. Or in 80%, you can see 20% is a type 2 error. Okay, so you have to just remember 80%, 90%. And you can see here, 1 minute, okay, yes. You have to see here, in front of this 80%, we have to write here normal deviate function z minus beta, 1 minus beta, z 1 minus beta. So z 1 minus 0.2, 0.2 means type 2 error, 20%. So when we are using this z 1 minus beta and beta is 20% or 0.2, it means power of study is 80%. If beta is 20%, so power of study is 80%. 1 minus beta, it means power is 80%. So corresponding z value you have to take 0.842. So you can write down z 1 minus beta, and if beta is 20%, so if beta is 20%, it means power is 80%. So here z value is 0.842. So you can write down, we will use this value when we calculate sample size. Okay, so no need to go for this 0.15 here. We have to see 0.1 in alpha type 1 error or type 2 error values. We have to take it 0.1. So here 0.1 means 10%. Okay. So if we are taking type 2 error is 10%, type 2 error is 10%, means beta is 10%. So what is power of study? 1 minus beta. We have to write down here 10% or 0.1. So it is coming 0.9. It means 90%. And we can write down in normal deviate function z1 minus beta, okay, is equal to z1 minus 0.1. So here, if we are taking beta is 10% or power of study is 90%. So if we are taking power of study is 90%, then this corresponding z value is 1.282. So what you have to remember, you can write down, if we are taking power of study is 80%, so z1 minus beta is 0.842. And if we are taking power of study is 90%, so z1 minus beta is 1.282. These are constant, okay? These are a tabulated z value, z table. There is a z table, and this is mathematical formation here, and we get these values. So what we have to do, we have to just remember these two values for calculation of our sample size. So z1 minus beta at 80%, it is 0.842. And at 90%, Z1 minus beta is 1.282. We have to remember two things. Okay, then what we have to do, every time we have to take 95% confidence interval. No need to take 99%, something like that, because 95% is standard. If you want to take 99%, you can take. Okay, so there is value is something else here. So for alpha, we have done for beta. So if you have any question, we will discuss, no issue. But you have to remember power of the study is 80%. What is Z value? Z value 0.842. Power of study is 90%. What is Z value for this? Z value means Z1 minus beta. 1.282. 1.282. Okay. Now we have to talk about alpha, type 1 error. Okay. So type 1 error is reject the null hypothesis when it's true. Reject the null hypothesis when it's true. Okay. So what about this? You can see here at alpha is 0.05. It means 0.05. It means 5%. Okay. 5%. And when we subtract this 5% from 100%, it is coming 95%. Okay. So it is on 95% confidence interval. So there are two types of studies, one-sided and two-sided. One-sided and two-sided. So what do you mean by this one-sided and two-sided? So first you have to remember this, then we will discuss about what do you mean by one-sided and two-sided. Please remember, in descriptive study, in single group study, in cross-sectional study, if you have only single group, okay, descriptive study and cross-sectional study, we have to take alpha by 2. Always we have to take alpha by 2. That is, if alpha is 5%, so in two-sided, it is alpha by 2. It means 0.025. Okay, half of this 5%, you can see here. And we have to write down here Z1 minus alpha by 2. And this is coming as corresponding Z value is 1.96. You have to remember this. For two-sided, you have to take this Z1 minus alpha by 2. When we have to use two-sided and when we have to use one-sided, we will discuss. But as I told you, in descriptive or cross-sectional studies, we have to always take this two-sided alpha, not single-sided or one-sided. So what we have to do, we have to take Z1 minus alpha by 2. Always we have to take this, and this is coming as Z value is corresponding Z value is 1.96. When we take one-sided, it means we are taking only alpha, not alpha by 2. So it is 0.05. If we are taking alpha by 2, it is 0.025. We have to divide by 2 it, okay? Then it is coming 0.025 or 2.5%. But if we are taking alpha, only alpha, in one-sided, always we have to take alpha, not alpha by 2. Alpha by 2, it means two-sided. So 5%, it is coming 0.05. So here what is Z1 minus alpha? That is normal deviate function. So this is coming Z1 minus alpha. And this corresponding Z value is 1.645. Okay, so these four things you have to remember. You can write down in your paper. So again, I will explain you, okay? So for 80% of power, what is Z1 minus beta? It is coming 0.842. What about 90%? Z1 minus beta, it is coming 1.282. Okay. And if there is Z1 minus alpha in sample size calculation formula, if there is Z1 minus alpha, so for Z1 minus alpha, you have to take this 1.645. But if there is written here over there in formula, sample size calculation formula, Z1 minus alpha by 2. So what you have to do? You have to write down this 1.960. You have to remember this. Okay. So one-sided, where we are using one-sided, we are using one-sided for superiority and inferiority trial. One-sided means one drug is superior than other. A drug is superior than other. So we are giving direction. This A is superior to B. So it is one-sided. Okay. So when we are calculating sample size for superiority and inferiority, then we will use this one-sided alpha. For others, we are using two-sided alpha. So please remember, if you are calculating sample size for superiority and inferiority trial, then we have to use Z1 minus alpha, and what is corresponding Z value? 1.645. And what do you mean by one-sided? A drug is superior than B. It means there is one direction, one-sided, one tail. A is greater than B. And what do you mean by inferior? Non-inferior or inferior trial? And non-inferior, it is non-inferior to B. A drug is non-inferior to B. It means we are giving direction. So this is for one-sided. What do you mean by two-sided? What do you mean by two-sided? So what do you mean by two-sided? I want to give example for this. Then there is a mean difference between treatment A and treatment B. There is a difference. So we cannot say A is better than B. We are just saying that there is a difference between. So different, it may be A is better than B or B is better than A. So there is no direction. It is called two-sided. A is better or A is worse. So it is called two-sided. Okay. So this is example of two-sided and one-sided. So one-sided you have to remember for superiority and inferiority trial. And for other designs, you have to take randomized control trial, whatever you have to take alpha by 2. Okay, two-sided. And it's coming 1.960. So please write down. For 80%, 1 minus Z1 minus beta is 0.842. 90%, Z1 minus beta is 1.282. For two-sided, Z1 minus alpha by 2 is 1.96. For one-sided, Z1 minus alpha is 1.645. So as I told you, one-sided only for superiority or inferiority. And in other trials, okay, like equivalence trial or other randomized control trial, we have to take always two-sided. So 1.96. And for descriptive or cross-sectional study, we are always taking two-sided, 1.96 value. Z1 minus alpha by 2, 1.96. So please remember these things, these values. You can write down. When we calculate sample size, we will use these values. Okay. Now, this is the example. This is formula. And formula, if you want to calculate sample size by using pen or paper, you can calculate using this formula. There are some online software you can use, like you have to fill these values, you will get sample size automatically, okay, without any like problem or error. But if we calculate sample size manually, then we are getting confidence. Then we can use sample size calculation, online calculator we can use. So it is called Cochrane's formula. Nowadays, what is going on? The name of the formula. What is the name of this formula? What is the name of this formula? So it is called Cochrane's formula. Okay. So what is it? We have to remember. So this formula is a sample size calculation for single proportion, single prevalence, single incidence, single percentage. I will give example for this. So there is single proportion, single prevalence, single incidence, single percentage. It means there is only one group. And this is formula is using for only for descriptive and cross-sectional. studies, descriptive, cross-sectional studies mainly. Okay, and it is called Cochrane's formula. So what is it? Is sample size. Okay, there is a number of sample or participant is equal to. Okay, and we can see, we can say greater than or equal to. Okay, so greater than or equal to sample size is equal to or greater than or equal to Z1 minus alpha by 2 square of Z1 minus alpha by 2 ka square. This is P multiply by P, then multiply by 1 minus P. Okay, and divided by D square. Sometimes 1 minus P is we can write down Q here, Q, PQ. Okay, PQ, Q. So what is Q? Q is a 1 minus P. So it is Z square PQ upon D square. It is very simple format of this formula. You can write down Z square PQ upon D square. Simple. Okay. And what is Q? Q is 1 minus P. Now here we have to understand about this. As I told you, Z1 minus alpha by 2. As I told you that Z1 minus alpha by 2, every time in cross-sectional or descriptive study, single proportion is a cross-sectional or descriptive study. Okay. So we have to take, it is single-sided, one-sided or two-sided. Alpha is divided by 2. It means it is a two-sided. Okay. It is two-sided. So 1 minus alpha divided by 2 is, we have already discussed it. It is a standard normal deviate function. And we have already discussed a two-sided 5% error is alpha. So alpha of 5%, we can say the value is 1.96. As I in previous slide, you can see here. 1 minus alpha by 2. If you are taking alpha is 5%, so 5 divided by 2, it is coming 2.5%, it is coming 0.025, and it is Z1 minus alpha by 2, and this value is 1.96. Okay, so you have to remember. And it two-sided 1% alpha, if you are taking, suppose to take only 1%, not to want to take 5% alpha, I want to take only 1%. So you have to remember the value of Z1 minus alpha by 2, what is 2.58. You have to remember this. It is not given in this table. Okay, it is not given in this table. So it is given only here. So you have to remember this. So 1 point, and mostly you have to use this 5%. So it is 1.96. Z is 1.96 at 5%. Z1 minus alpha by 2 is 1.96. And what is P here in this formula? P is estimated proportion, percentage of that event of interest or primary outcome, or prevalence or incidence in population based on previous studies or pilot studies. So if we have previous studies of this prevalence or proportion of that event, we can take it. Otherwise, we can take we can have a pilot study data, 10 patients or 5 patients, and we can calculate prevalence or proportion or percentage or something like that. We can assume this, we can take according to our clinical experience, or we can take an expert opinion for this P. Okay. Then D, what is D? D is it is called margin of error, absolute error or precision. I will give demo on this, what is D. So it has to be decided by the researcher. So we have to decide for this. Okay. So this is Cochrane formula. It is called Cochrane formula for sample size calculation for single group proportion or percentage or prevalence. Okay. So here we have to write down this paragraph in our research paper, article or dissertation. So what, according to previous study, because researcher find out a previous study which may be conducted in other part of country or outside of this country. So according to previous study, 10% of the patients with, you can give disease name or condition name. For example, patients with TB, okay, glaucoma, whatever, had delayed revascularization. And what is delayed revascularization? That is, according to previous study, it is 12 to 48 hours. We can write down anything here, and we have to give reference. So from which study we have to, we took this 10% of patients, okay, with TB or glaucoma had this delayed revascularization. So delayed revascularization, it is our primary outcome of interest. So how much patients, how many patients? 10% of the patients, okay. So it is a qualitative type of, categorical type of, okay. Then what we have to write down? Assuming similar finding in our study, we have to recruit 140 patients. How we calculated 140 patients? In next slide, I will explain you. With 5% margin of error and 95% confidence interval. So what is 5% margin of error? We can say here in this formula, what is margin of error? B. B is a margin of error or absolute error or precision. That is a D, okay? That is, what is 95% confidence interval? That is a, this is alpha is a 5%, okay? Type 1 error is 5%, so confidence interval is a 95%. So as I told you here, that it is a single group. It is a cross-sectional study, descriptive study. So here Z1 minus alpha by 2. And the value of at 95% confidence interval or 5% of type 1 error, that is the alpha. What is Z value? Z value is a 1.96. So we have Z value, we have D value, that is a margin of error. So what is margin of error? In previous study, it is 10%. Outcome of interest is 10%. But in our study, it may be 10% plus minus 5%. That is a margin of error, plus minus 5%. So in our study, it may be, it ranges from 5 to 15%. So this is meaning of a margin of error. In previous study, it is a 10%. Okay. Delayed revascularization. Percentage of the delayed revascularization is 10%. But in our study, what we are assuming? We are assuming there is a 5% margin of error or absolute error. So in our study, in our population, in our sample, it may be vary from 5 to 15. So what is 10% plus minus 5%? That is a margin of error 5%. So first, if we subtract this 10 minus 5, it is coming 5. And if we add this 10 plus 5, it is coming 15. So in our study, it is ranging from 5 to 15%. It may range. Okay. So it is meaning of margin of error. And please take margin of error, okay, not more than half of this prevalence. That it is coming 10%, we can take 5% of margin error. But if you are taking margin of error is 8% or 10%, so I think it is not, we can say, ethical, we can say ethical, because 10% means 0 to 20%. So range is, we can say there is a wide, okay? There is a wide. If you are taking margin of error is 10%, Okay. So in our study, the percentage or prevalence of this delayed revascularization ranges from 0 to 20%. 0 means there is nothing. Okay. So please always take margin of error half of that prevalence or percentage. So it is 10%. So take margin of error, you can take up to 5%. You can take 4%, 2%, 3%, whatever. But please avoid to take more than half. Suppose if you have percentage of the patient with delayed revascularization is 25%, suppose 25%, or anything you can remember, any you can assume. Okay, then you have to take margin of error not more than 12.5, not more than half of that. If you are taking 25%, not more than this half of that 25%. So not more than 12.5%. So this is like a general rule for to calculating sample size. Okay. So this is Cochrane formula you can remember here. You can see here, this is formula Cochrane. N is greater than or equal to Z1 minus alpha by 2 chi square, P1 minus P, or Q. You can say Q here, 1 minus P divided by D square. So you can see here in this example, we can write down this according to this. Okay, Z N is equal to greater than or equal to Z square. So please remember here Z means 1 minus alpha by 2, or Z value is 1.96 here. In this formula, Z value always will be 1.96. No need to remember anything. So Z is 1.96. This is P multiplied by 1 minus P divided by D square. So what is D? What is Z? So here you can say Z is equal to 1.96 at 95% confidence interval. It is very simple. P is 10%. So where we got 10%, we can see here, this is 10% of the patients. Okay, this is proportion prevalence of this disease. We can see. So this is Z is 10%, it is coming 0.10. P is 5%, it means 0.05. When we converted this percentage into proportion, it is coming 0.05. This is our formula. We have to put these values. You can see here. This is Z square. You can see. So Z value is 1.96. Always 1.96. So you have to make it square. Multiply by P 0.10. Multiply by, this is a star means multiply in bracket 1 minus 0.10. 0.10 means P, prevalence of that. Okay. So in your study, what can be like, what are changes you can see here? P, you can change P here, you can change D here. Okay. But Z square is a constant, you can see 1.96. But you have to remember your primary outcome. What is your primary outcome of your study? And in D, you have to write down 0.05 chi square. You can square of 0.05. Then when we multiply it 1.96 square, then it is coming 3.84. Multiply by 0.10, multiply by 0.90. Okay. And when we square it 0.05, it is coming 0.0025. And when we solve this equation, we are getting 138.24 is equal to 139, because we have to take whole number. We are taking samples, patients. We cannot take 138.24. So we have to take whole number. And when I round it, it's like 139 or 140 I can take. Greater than or equal to, it means I can take 140. So 140 patients I have to recruit in my study if my primary outcome is a delayed revascularization in 10% of the patients according to previous study. Okay. So what is para? And this is adjustment for dropout rate or loss to follow-up. So sometimes there is a non-response rate also, and it is mainly happen in longitudinal or follow-up study. Okay, and it may happen in you can say in descriptive study also. Okay, so this is formula for the adjustment for dropout rate or attrition rate. So you have to remember this formula. NA greater than or equal to NB divided by 1 minus D. Okay, here D is a different thing. Okay, in capital. Okay, so here NA, what is NA? Sample size after adjustment of the dropout or attrition rate. And what is NB in this formula? Here NB, total sample size before adjustment. And what is D? D is a dropout rate, loss to follow-up rate, non-response rate, or it is called attrition rate also. Okay, so that is if we are usually we are taking 10%, 20%, not more than 30%. Please don't take 30% loss to follow-up or dropout rate, not more than 30%. Usually we are taking 10%, 20%. You can take 5% also, according to like condition of disease or like patient's follow-up. If we are taking 10%, suppose a 10% dropout rate or loss to follow-up rate or attrition rate, the final sample size would be NA. This is formula, okay? NA. NB divided by 1 minus D. B means before, sample size before adjustment. So this is 140. We have calculated 140 here. It is before adjustment. So we have to write down here 1 minus D is 10%. So it is 0.10. Okay. So it is 1 minus 0.10. It is coming 0.9. So 140 divided by 0.9. And when we solve it, it is coming 155.55. It is 156. We have to take always in round figure. So with 10% dropout rate, the researcher has to recruit total 156 subjects or participants instead of 140. So this is adjustment for dropout rate or loss to follow-up rate. So this is for single proportion. So if you have any question, you can type, we will discuss. You can message me about this, WhatsApp me if you have any like study related to your descriptive or this type of outcome. We can calculate sample size, but I think it is very easy to calculate sample size. Okay, now we can see here complete paragraph. We can write down here sample size calculation. Okay, according to previous study, 10% of the patients with glaucoma had delayed revascularization, that is 12 to 48 hours. We have to give reference here. Assuming similar finding in our study, we have to recruit 140 patients with 5% margin of error and 95% confidence interval. Anticipating 10% non-response rate, we have to recruit 156 patients in our study. This is complete paragraph. We can give this and this in our sample size calculation paragraph also for more understanding. We can even write down Cochrane formula, using Cochrane formula. We can impress the reviewer also, okay, for this single proportion. Now sample size formula for single mean. Okay, so what is sample size formula for this? And I think it is not have any name. If you have any name for this formula, please send me. Please, you can share on this group. Okay, it is very good thing. So this is a sample size formula for single mean. Okay, it is like in descriptive or proportion study, like cross-sectional study. So here coming Z1 minus alpha by 2. So as I told you, in descriptive or in cross-sectional study, use Z1 minus alpha by 2. It is the value you have to remember. At 5%, it is 1.96. Always. Square, SD square divided by D square. So what is SD square? Because it is a mean. So in mean, there is a standard deviation also. Okay. So this is standard deviation. We are calculating sample size with mean, but we are not using mean in this formula. You can see this formula, there is no mean. Okay. We are using SD, standard deviation, not using mean. So here Z1 minus alpha by 2, it is a standard normal deviate value, and at 5%, it is 1.96. You have to just remember this. SD, what is SD? It is a standard deviation of variable. Value of standard deviation can be taken from previously done study, through pilot study. We can assume, we can have clinical expertise, we can take expert opinion also for this SD. Okay, so no, there is no like boundary for this. There is no limitation. Sometimes we don't have similar study. Okay, so we don't have SD from previous studies. So from where we can take SD, we can do a pilot study, but sometimes we cannot do pilot study. So we just take expert opinion or clinical experience, we can take SD. Okay, and we can assume also. And it is also margin of error or absolute error or precision. Okay, so with the one example, we will like discuss this formula. According to previous study, and we can write down according to, like we can write down first author name here, there is no problem. According to Kumar et al. Okay, we can write down here mean HB, mean creatinine, mean systolic BP, mean. This is for quantitative. Oh, sorry. Sample size calculation for single. This is not a proportion. It is a single mean. Okay. So there is some typo error here. You can see here. Okay. It is a. Okay. Yes. So it is for single mean, not proportion. Because HB is a mean here, not proportion. Okay. So sample size calculation for single mean in one group. So according to previous study, mean HB, mean creatinine, mean health-related quality of life, mean satisfaction score, mean exam score, mean knowledge score, mean practice score, whatever, was 11.5. And SD, from previous study, we are taking this. SD is a standard deviation, that is at 2.4. 11.5 plus minus 2.4. So that is plus minus 2.4, that is SD. Gram per deciliter. In patients with, we have to write down disease or condition name. Patients with, you can give any SLE or something, any population, you can say in women, in any condition or disease, you have to give name. And we have to give also reference of that study. Okay, if you are taking from previous study, if we are taking, so we have to, according to our clinical experience, mean HB, we are taking this with SD. So we can write down according to this. Assuming similar finding in our study, we have to recruit 90 patients with 0.5 gram per DL of margin error in mean HB and 95% confidence interval. We have to write down 95% confidence interval. So why we are writing here 95% confidence interval? Z value. So what is Z value? If we are taking 95% confidence interval in single mean in descriptive study, so that is a 1.96. Okay, and this is margin of error. You can see this is margin of error is a mean of that. It is mean of HB, mean of any quantitative variable, mean of systolic BP, mean of sleep hour, mean of practice score, mean of knowledge score, but it's only single group. You have to remember single group. Descriptive study or cross-sectional study, we can see. So margin of error is 0.5 gram per DL of in mean HB. So in this study, the mean HB is 11.5. But in our study, mean HB is ranging from 11.5 plus minus 0.5. So when we subtract it, so it is coming 11. And when we add this margin of error in 11.5, it is coming 12. So in our study, we assume that the HB, mean HB may range from 11 to 12. You can take margin of error whatever you want, but it is for just an example, hypothetical example. Okay. So this is sample size calculation. Sample size calculation for single mean, one group mean, descriptive study or cross-sectional study. It is n equal to and greater than. Please take always equal to or greater than z square SD square upon D square. So where is Z square? Where is 1 minus alpha by 2? You have to just remember. 1 minus alpha by 2, you have to just remember. Z square SD square divided by D square. So what is Z? At 1.96 at 95% confidence interval. What is SD? SD is 2.4. Standard deviation is always unit free. We know that standard deviation is always unit free. So it is 2.4. And D is what is margin of error? It is 0.5 gram per DL. When we put these values here, so you can see here 1.96, it is a Z value square multiply by 2.4. What is 2.4? This is SD square. And what is 0.5 square? It is a D square. When we solve this, okay, so we are getting this 22.12 divided by 0.25. It is coming 88.47. It's equal to 89 because we cannot take 88.47. And please don't take 88. We have to take more. Okay. It is not we can take 88. No. We have to take more. More than 88. So it is 89, or we can in like 90 is like looking very nice. So we can take 90. So this is a sample size calculation for single mean. Okay. Now again, adjustment for dropout rate or loss to follow-up. So what we have to do? We have to remember that formula. NA is equal to or greater than, where is my cursor? Okay, here. Equal to or greater than NB divided by 1 minus D. NA is after NB. B means before adjustment. This is NA means after adjustment. And what is D? D is a dropout rate or attrition rate or loss to follow-up rate. D. Here D is capital. So here we have done, okay, right now we are taking 20%. In last example, we have taken 10% of the attrition rate or dropout rate. But here we are taking 20%. So what will be our sample size after adjustment? It is NA equal to greater than NB divided by 1 minus D. So we have to write down here NB is 90 because we have calculated 90 here. We can write down 89. There is no problem. But we have to write down 89 here, not 88.47. Either 89 or 90 we have to write down. Okay. I have just given 90 here. 1 minus D. What I'm taking? 20%. So here 20%, that is 0.20. So I have to write down here. It is coming 90 by 0.8. That is coming 112.5. And in round figure, it is 113. So with 20% dropout rate, the researcher has to recruit at least 113 subjects or participants or patients instead of 90. So we have to adjust for this dropout also. And we have to recruit this much of the participants, not 90. Okay. And for paragraph. So what we have to write down here. So according to previous study, mean HB was 11.5 and SD is 2.5 gram per deciliter in patients with any disease or condition. We have to give reference also. Assuming similar finding in our study, we have to recruit 90 patients with 0.5 gram per DL of margin of error in mean HB and 95% confidence interval. Anticipating 20% of loss to follow-up or non-response rate, we have to recruit 113 patients in our current study. So we have to write down dropout, with dropout rate, we have to write down sample size also in third line. And we can make paragraph also. There is no need to in point, we can make a paragraph for this. Okay, so this is, now let's have hands-on practice on online software. So when we do this sample size calculation through using pen and pencil, we can do according to this, but we don't have time. There are might be some error during calculation. Then we can do sample size calculation using these online software. And very famous software is OpenAPI. It is very free of cost. Statulator is second, CleanCalc third, and there are many software to calculate sample size. OpenAPI is very famous. Okay, OpenAPI is very famous to calculate sample size in public health and also in like clinical research. It is very famous. It is free of cost. There are some mobile app also to calculate sample size, mobile applications, mobile app. And these mobile app give results within 1, 2, 3 seconds, 5 seconds. But what we have to remember, we have to understand these things before calculating a sample size. So what is this is very important to calculate a sample size, and these are the prerequisites for sample size calculation in health research. So please remember, you have to calculate sample size on the basis of primary outcome. If you have only single outcome in your study, that is your primary outcome. Okay, so there is no problem. Okay, which is my primary outcome? If you have single outcome in your study, so that single outcome is your primary outcome. But if you are more than single outcome, more than one outcome in your study, research study, then there must be one primary outcome. You have to take primary outcome, one, and then you have to calculate sample size. Then we have to remember these, what is qualitative, categorical, and continuous variables. So for categorical variables, we will do sample size using proportion, prevalence, incidence, and percentage. And if we have quantitative variable, we have to do for mean and standard deviation. Sometimes mean and standard deviation are not given in previous studies. They are giving median and interquartile range or range. There are some other methods to calculate sample size using median and interquartile range. We can take, if we don't have previous study, we can do pilot study on a small sample size, 5 or 10, expert opinion, clinical experience, or assumption, or okay, we can assume. Then we have to remember power of study, always take 80%. You can take 90%, no issue. But you have to remember, if we take 90%, then sample size is greater than 80%. So what is sample size we are calculating for 80%? When we calculating sample size 90%, it will be more than 80%. Suppose we are calculating sample size for prevalence study or single mean, there is no power. There is no power, please remember. For single group or descriptive study or cross-sectional study, for mean or for proportion, there is no power use. There is no power of, okay, there is no use of power of this study. Only confidence interval. You have to remember this. Okay. So if we are getting, if we are calculating sample size for two group or more than two group, we are comparing, okay, mean or proportion we are comparing, then we have to use power of study 80% or 90%. So if we are calculating sample size 80% and suppose it is coming 50, okay, participants, and for similar study, if we are calculating sample size for 90%, it will come more than 50. You have to remember this. It will come more than 50. So according to feasibility, you have to take 80% to 90%. If you are lot of patients, okay, there is there is no paucity of the participants or patients, okay, you can get easily, accessibly, feasible, then you can go for 90%, otherwise 80% is sufficient. But always use confidence interval 90%. You have to remember this table, only 4 figure you have to remember. Z1 minus beta, that is for 80%, it is 0.84. When we, as I told you that power of study, that is beta is for power of study, 1 minus beta. So when we compare two or more than two group, then we will use this. Otherwise, for single group, there is no need of beta. There is no need of 1 minus beta, Z1 minus beta. We only need Z1 minus alpha by 2. So we have to remember these 4 values, these formulas. This is Cochrane formula. These are the examples. Okay. And now we are going for hands-on practice. So with OpenAPI, I will do this. Okay. OpenAPI. Okay. So I think we have time for 15 minutes, so we can do. Okay. So what do we have to do? We have to open our Google. We have to Google. And here, what we have to do, write down here in Google, we have to write down just Open API. Okay. You can get app for this Open API, no issue. And we have to click here, Open API. Then this window will open, Open API menu. You can see here.
So sorry to interrupt, sir. Your screen is not visible, sir.
Okay, okay. My screen is not visible. Oh, so yes. It's not visible. No issue. Sorry. I have to entire screen. I have to do. Sorry. Thank you. Now it's visible.
Yes, sir. Now it's visible, sir.
Yes. So in Google, what we have to type here? We have to type here Open API. Then we have to enter. Then this window will come, Open API menu. I think most of the participants know about this. And if who are not knowing this, I think it is very beneficial for them. So what we have to do, we have to click this Open API menu. Here, this window will open. This screen will open. Okay, it is visible, ma'am?
Yes, sir, it is, sir.
Okay, so it is open source. It is open source epidemiological statistics for public health. Okay, we can use for, I think, clinical research. We can also use it. It is version of 3.01, updated is 2013, but it is very up to date. Okay, and try it in a smartphone browser also. This like online software will give accurate result, so no issue. So for sample size, we can see here in the left side, you can see here home, info, help, count, person time, continuous variable here, and here is a sample size you can see. Okay, in left side menu you can see. Then you have to click this sample size. When you click this sample size, this will come. You can see here. You can see here it is a plus. When you click here, this will come. These are the options. And we have to click on this proportion, single group proportion. Okay. Z square P multiply by 1 minus P divided by D square. That is our formula. We have to click this proportion. When you click this proportion, this window will come. Okay, I think it may take some time, no issue. So ma'am, in between, if any participant have any question, we can discuss on those questions, no issue.
Sure, sir.
Yes.
So the first question is, can we say like alpha 20%, then beta also 20% is being taken, and par 1 minus beta equals to 80%?
What do you mean by that? Is 1 minus beta. If we are taking 20%, it is 80%. But what is? Kindly repeat it.
Can we say like alpha 20%, then beta
No,
also
cannot.
20%?
No. We usually we are not taking alpha as 20%. We are taking only 5%. Okay. But if we are like alpha is 20%, we can take like alpha and beta are similar. Okay. But usually we are taking 5%. We are taking 1%. Usually we are taking 5% or 1%. Never take beta more than alpha more than 5%. Never take. Okay. So just remember, alpha is 5%. We can take beta 80% or 90%, whatever. Okay. So
when okay.
Next question, ma'am.
So when alpha is 5% or 2.5, what beta and par will be?
Oh, that is separate thing. We have to like we can take beta 80% or 90%. So there is no something like calculation between this. There is no relationship. We can take separately at beta, and we can like power of study. We can take separately, and we can take alpha separately. Both are different things. Okay. So you have to take power of study, that is a Z1 minus beta is 80% or 90%, or alpha is 5% or 1% or 2.5%. Okay. So you can take beta is 80% on alpha is 5%, or you can take beta is 80% on alpha is 2.5%. So there is no problem. Next.
So next question is, kindly explain margin of error again.
Margin of error is, I think 2-3 times I have already explained, but margin of error means suppose in study or in study we are taking this proportion. For example, 20% of like participants or patients like had this event of interest or primary outcome. Okay, for example, death or complication or bed sore. Okay, in one study. So 20%. Okay, so what is margin of error? In our study, we can assume that this the outcome of interest in previous study is 20%. So in our study, it may be vary according to margin of error. So suppose margin of error, if we are taking 5%, so in our study, it is from, if we are taking 20%, so it is 20 plus minus 5% means 15 to 25%. In our study, we can get these results. So for these results, we have to recruit how many patients we are calculating. Okay. Next.
So next question is, what if there are no dropout rate after follow-up, but actual we required NB?
Okay. If you are thinking that there is no dropout, then no need to calculate this, no need to adjust your sample size according to this. If you think that there is no, but because in longitudinal study, in follow-up study, usually there is a dropout. We are thinking that there is a dropout. 99% there is a dropout. So we are calculating or adjusting for this. So if we are taking, and for dropout, we are taking more sample size. So always take more than calculate sample size. So it is very beneficial for us. So no issue, because we cannot take less sample size what we are calculating. If we are calculating 40 sample size, and if we are taking like recruiting 50 participants, so it is very good. But if you are calculating 40 samples and if you are recruiting only 30 samples, so there is might be a question from reviewer. But if you are taking more than this, so it is very good, no issue. Okay.
So, next question is it's from Kavitha, and she's asking that she's doing a study on shoulder range of motion is one of the outcome. If I have SD of range in 4 different direction, that is flexion, extension, abduction, add, which SD can I use for sample size calculation?
Oh, very good, very good. So what C has to do, that C has to calculate sample size for all SDs, and which is a bigger sample size she has to recruit. She has to calculate sample size for all SDs differently, okay, and then she has to recruit participants which is like coming bigger, more in number. Okay, so this is a general principle for sample size calculation. Okay.
Yes, sir. For experimental studies with 2 groups, which formula should I use?
Okay. I think I'll explain tomorrow on this 2 samples, 2 groups. So it is like I'll explain you. I'll discuss tomorrow on this randomized control trial and 2 group sample size. Both for the like randomized control trial and 2 groups, we are using similar type of formula. So I'll discuss tomorrow on this. Okay. Thank you.
So then the next question is two-sided type 1 error 5% means 2.5% each side.
Yes, each side. Very good. 2.5% each side. Very good.
Okay. Then, sir, what will happen if the final result vary a lot beyond margin of error?
No, because we cannot control all the things. So it is like vary, so it goes, we have to report it. There is no problem. We have to just report it. So no issue.
Okay. What if primary outcome involves 2 or 3 things, which to be included?
Okay, so in like shoulder flexion वगैरह SD, so you have to calculate sample size using all 3 or 4 parameters, and bigger sample size, which sample size is bigger, you have to recruit patients using that. Okay.
Yes, sir. Do general journals accept sample size calculated based on expert opinion because it will not have any reference?
Okay, because if like there is no study, then you and like uh, the general, what you have to do, you have to can conduct pilot study. Otherwise, like clinical expertise or on the basis of assumptions, they are like accepting manuscript. There is no problem.
Okay. So, sir, if the prevalence is 60%, so can we take margin of error up to 30%?
You
I
can take
think,
no. You can take 30% or 10% or 5% or 20%, up to 30%. You can take, no issue. Okay, you
so,
can take
sir,
30.
okay. So, sir, in that case, the power of effect won't vary.
No. As I told you that in margin of error, like in single proportion and single mean, there is no power of study. Power of study is only for 2 group comparison or 3 group comparison. So there is no meaning of power of study in single group. So there is no need.
Okay, sir. is it okay to take a bigger sample size than what is actually calculated?
Yeah, if you are taking, like, suppose you are calculating only 30 and you are taking 300. So I think it's not a use of calculating sample size. But you can take, if you are getting 30, then you can take 40. Okay, you can take 50. But if you are taking 300, it's I think 10 times more. So I think it's not a logical thing.
So
Then you have to calculate sample size according to 300.
okay. So Sevika is asking again. She has also asked previously that which calculation, which sample size should we include. Over here, she has given the example that if we are assuming that exercise, blood test, anthropometric measurements are predictors of diabetes, then which one to be included in the calculation of sample size?
Okay, so you have to calculate sample size according to, if you want to calculate sample size and if you want to take all these things, it is your primary outcome. So first you have to make only your single primary outcome. Okay, only single parameter for your primary outcome. Other you have to include in co-primary or secondary outcome. Number one thing. But if you want only, like in primary outcome, you have to include all these parameters. So what you have to do, you have to calculate sample size on the basis of HB, on the basis of what 3 and 4 anthropometric measurement and any other things. You have to calculate sample size for each one of these things. Then bigger sample size you have to take. This is a rule.
According to error, which one is more dangerous? Either it is type 1 or type 2.
Okay, so both are like dangerous. In some books, they are written like type 2 error is more dangerous. And in some, there are type 1 error is more dangerous. So according to situation, okay, if we are going in pharma, then type 2 error is more dangerous. If you are coming in health research or public research, then type 1 error is more dangerous. So we cannot say it is more than this. Earlier I was thinking that type 2 error is more dangerous. Then after that I when I studied more and more, then I got that no, in some condition type 1 error is more dangerous, then in some condition type 2 error is more dangerous.
If you want to calculate sample on ICC, we follow the same formula of proportion or SD.
What do you mean by ICC? Intra-class correlation.
I have okay.
That is, I think this is, but for ICC, if it is intra-class correlation, don't use this formula. This is for that sample size formula is like another sample size formula you have to use. But this is only for proportion and mean.
Okay, sir. Sir, tell us some.
20 minutes left, so I'll give demo on this Open API. Okay, then we will discuss later all these. Okay, on 5 minutes I will take. So this is our Open API. You can see here we have to click on this sample size here. When we click this sample size here, you can see in left side menu. Then we have to click on proportion. When we click on proportion, you will get this window. Okay, and then what you have to do, I have to enter new data here. I have to click on this enter new data. So I have to click this, then this will come. Okay, then in this Open API, you have to population size, you have to take at it is like 1 billion for large population. Okay, we have to take, so please don't do anything for infinite population. For finite population you can change it, but for infinite population and large populations, don't change this. Okay, then this is anticipated percentage or frequency, and here between 0 and 99.99. If unknown, if you don't know, then use 50%. If you don't know, if you don't have any similar study, if you don't have any pilot study, So you can take 50%, okay? And you can give reference of this Open API. So here anticipated percentage or frequency, here we have to write down in single proportion. It is a single proportion, okay? Sample size calculation for single proportion in descriptive or cross. So when we remember our example, so that is proportion is 10%, okay? Percentage 10% of a delayed revascularization. I have to write down here 10, okay? Then confidence limit is plus minus percentage of this, okay, here. And this is a absolute precision. This is a absolute error. This is a margin of error. So in that example, we have taken 5%, if we remember. And for design effect, please keep it as 1. Okay, please, you have to keep it as 1 for design effect in Open API. Please never change it. Okay. Then when I click on calculate here, this is calculate button. If I calculate here, we can get this result. Confidence interval at 95%, sample size is 139. Okay, so this is a result from Open API. We can see, and when we see our example, there is exact around 139 or 140 we have recruited. Then you can correct for adjustment also. Okay, you can correct for adjustment. So this is a sample size calculation from Open API. So what you have to do, again, if you want to calculate sample size, what you have to do, you have to click on enter this. This is a result. Example, help, start. If you have any like doubt, you can click on help. You can get help from this. And if you want to like change anything, if you recalculate sample size, then you have to click on enter. Then this will come. And suppose if you want to decrease this margin of error or absolute precision by, suppose if you want to take 4%, suppose if you want to take 4%, then click OK. Then this will come at 95%. It is coming 217. Okay, this much. If you want to, suppose if you want to increase this margin of error, so what you have to do, you have to click enter. Then you can increase up to 6. Suppose 6. Please don't take more than 5 or 50% of this percentage. So suppose 6, then calculate. This is coming at 95. Always use 95%. This is coming 97. If you want to take 99%, you can take. It is coming 166. But please, I recommend, please go for 95%. Don't use 99%. Okay. So it is on 95% is coming 97. So what you are, here is a conclusion. If you are increasing margin of error, sample size is decreasing. If you are decreasing margin of error, sample size is increasing. So you can like do sample size calculation according to this, and whatever is suitable for you, feasible for you, you can take that sample size for your study. Okay. So this is Open API. Tomorrow I'll give on like ClinCalc and Statulator. Okay, examples, hands-on examples. So it is very famous. Okay.